Hi there, and welcome to the screencast on circular motion. This is the last screencast for the IB Physics Core Curriculum Topic 2 about mechanics. Yay! So let's get started. Okay, so let's talk about objects moving in a circle. So this could be a planet moving around a star. It could be you twirling something on the end of a string over your head or in front of you. But we're going to say the object is moving around the perimeter of the circle at constant speed. Okay. The velocity, however, is changing. Why is that? I'll let you think about that a moment. Yeah, the velocity is changing because the direction is changing. Remember, velocity is a vector, right? So although the speed is the same everywhere, it's changing direction. Now, velocity is changing. By definition, we have some kind of acceleration. So let's investigate that further. So here's an object moving around the perimeter of a circle. And at some time here, it has a velocity, say, a. And at some later time, it has a velocity b. We're going to want to find the change in velocity. That's going to help us define acceleration. We're going to do a little vector work here, geometrically. So we're going to take the difference between the two. In other words, the final minus the initial gives us our delta in velocity. So let's move over here. We'll work over here. Here's VB, and here's VA. But we don't want VA. We want to subtract. So we need to turn A around. And we're going to add these two. So VB plus a negative VA, right, the opposite of VA, which will give us this quantity down here, delta V. So let's add them. Make a triangle. There you go. So the delta V looks like that right there. So this vector is how much the velocity is changing. If we copy this over to our circle, we can see that, right, we're going to put it halfway between the average position here. So over this interval, the acceleration is pointed directly at the center of the circle. You can do the same thing for any 2 points on this perimeter, and it'll work out the same. This delta V will be pointed towards the center of the circle. And that defines the acceleration. Now, if there's an acceleration, right, we have a velocity here. The acceleration, centripetal acceleration, is toward the center. Right? There must be a force also directed towards the center. That's called centripetal force. So we have an example of a video here in the background. It's kind of running. Let's see if I can get this one back to that. Here we go. If you watch Mr. Sellers here swinging around this object, you can see he's constantly pulling that ball inward along that string. Might be hard to see, but you can play this number right there. He's pulling it inward towards the center, and now he's pulling it inward again. Okay. Let's come back to our screencast. So if you had trouble seeing that, you can play this again. Just go to this link. You can click on it in my PDF file that I put online, upload. So centripetal acceleration, let's quantify this with some values. All right, so we're going to define this as the square of the velocity over the radius of the circle in which it travels, circular path that it travels in. That deserves a box. The centripetal force, well, if we know force is mass times acceleration, we just multiply this quantity here by mass, and we have centripetal force. One last thing I'll mention about circular motion. When an object is traveling in a circle around circular motion, is there any work done on it? I'll let you think about that for a moment. Well, in this case, right, the force is towards the center, but the motion is always tangential. Right, so the force is always perpendicular to the motion. If that's the case, right, remember, only the part of the force that's in the direction of motion contributes to the work. In this case, for circular motion, no work is done by a centripetal force. Now, we can see how that makes sense, right? If the work is zero, that means the change in the kinetic energy is also zero. Well, it's moving at constant speed, so its kinetic energy is not changing. Okay, that's your ends the screencast and ends our topic 2 about mechanics. Bye.